Linear combination, what we learned yesterday. That's our third method of solving a system of equations, right? Everybody remember the other two?
Adding.
What?
Adding them.
That's linear combination.
Substitution. Yeah.
Substitution is another algebraic way.
Fraction.
And yeah, solving graphically, right? Solving graphically, where do you find the solution to the system? Does anybody else know that? They intersect, right? Okay. Something else with it. This is 5, 4. Is that right there? I see. Okay. So a little more of this. Just make sure we're okay at it. And then I think I'll probably show you maybe how to solve them on the calculator. So in part A, exercise 1A, we got 4x plus 5x equals 12 and negative 2x plus y equals 8. Somebody, maybe other than Emily, Trinity. If we were to add these two equations together, would either of the variables disappear? No. But is there something you could do to one or both of them to make that happen? Serenity. What is that thing? You said yeah. No, we're going to add the equations together. But they won't make a variable go away. So we could multiply one or both of the equations by something. What do you think we should do? Which one? So then we'd have 8x plus 10x equals 24. And then would 8x minus 2x equal 0? What about the bottom? All right, let's try that. Let's multiply the bottom here by 2. Make it look like this, yeah? So we get 4x plus 5y equals 12. And what do we get on the bottom now? Negative 4x plus 2y. What? Equals 16. Now when we add them up, is anything going to go away?
Yeah.
Yeah. So these go away. And what do we have?
7 equals 28.
28. And what does y equal?
4.
4. All right. Are we done?
No.
What do we need to do now? All right. Want to plug it back into one of those? Anybody have a choice?
Top.
You want to do the top? All right, we'll do the top. So we'll say 4x plus 5 times 4 equals 12. X plus 20, yeah?
Oh, wait.
Do I have to keep showing when I subtract the 20 from both sides? You guys get that, right?
Yeah.
I know. So 4x equals what? It's 12 minus 20. Negative 8. So what does x equal? Negative 2. Let's go ahead and list it as an ordered pair. It'd be what, comma, what? Yeah? All right. So raise your hand if you kind of understand how to solve by linear combination. Yeah? So that's 3 of you. No? Serenity? Yes or no? Okay. But I want you guys on your own to try part B here. Okay? Ask if, can I add them as they are? Oh, wait, that's the same.
It's the same one.
Oh, okay. Yeah, I guess I didn't notice. It said, this one said eliminate. We got lucky. We eliminated X because it said to. All right, same thing, but now what? What do they want to do?
Eliminate Y.
So we can do either. Everybody agree we'd have to multiply by negative 5?
Yes.
Yeah? Okay, let's just do it that way. Which one, by the way? With the top or bottom? Because we need 5y and we need a negative 5y to make that happen, right? So 4x plus 5y equals 12. And what's on the bottom? And Emily, no. That's, wait, a positive 10x minus 5y equals negative 40. Add them up. 14x equals negative 28. Yeah? Okay, stupid, sure, yeah. So what's x equal? Negative 2. What do you want to go back in and find y with? I'm going to do the second one. So negative 2 times negative 2 plus y equals 8. 4y equals 8. Subtract 4 from both sides. So we have negative 2. Hey, same. How about that? So you can eliminate either variable first. Doesn't matter. Sometimes one of them looks a whole lot more convenient to get rid of first, right? Okay? Than the other one. But let's, why don't you guys all take a second and get up and grab a calculator here. I want to do something. Hey, when you enter the graphing thing, it was always f of x equals or y equals form. So there's two things we could do. One, we could solve both of these for y and get them in y equals stuff. But there's another way that this calculator will do. Yeah, open yours. We'll do it in Scratchpad.
Scratchpad like normal Scratchpad?
All right, so we don't have to open like a new document to do this. There'll be times when we do for other stuff, but we can just do the Scratchpad. Remember, you hit it once, and if it doesn't come up with the graph, tap it again. See, when you hit this, it just goes back and forth between the two, right?
I was just doing that.
So now see that says f of x equals, right? So that's presuming you have it in y equals whatever form, right?
Yeah.
But these equations aren't. Again, we can make them into that form. A little more work. But there's another way to do this, okay? So I can either hit the delete key to delete that equal sign, right? And you'll notice, what does number 6 say? Okay, let's hit escape for a second. There's another way to get into there. Hit escape. Now hit the menu button. You see choice 3 is graph entry, edit, like pretty much where we just were. But now we can get some more options here. Function is the way it was, where it's f of x equals stuff, right? Yeah. Your ear is bleeding? Yeah, well, we should probably go fix the bleeding ear. Or here's relation again. So, since our equations are in a form other than y equals, let's select relation. Okay? And we can now type it in the way it looks in our book. Okay? Let's take the 4x plus 5y equals 12. Oops, here. So just type 4x down here plus 5y and equals 12.
Where's the equals?
Right under the control.
Got it.
Now just hit the down arrow and type the other one in.
And just type in 4x.
The other one was negative. Remember, for like a leading negative, you got to use that little negative below the 3.
Yeah.
Okay? So negative 2x plus y equals 8. Oops.
You were drawn on your type.
Negative 2x plus y equals 8. Okay, so those are the graphs of our two equations. Everybody see where they, well, do you see where the solution of the system is?
Equal sign, let alone.
Right.
Now that you found it once, you know where it is, right?
I got the first one.
Okay.
How do I get to doing the second one though? I was worried about the first.
Well, you just, okay, you just had to push the down arrow to go to the next field. But now, just hit your tab button again, it'll take you back up to the next open field.
I can try to be there, but I
And
need this.
type this second equation. Well, don't do it for, make sure she knows how to do it if you're doing it, right? Because if this happened on a test, you both get a 0, okay? So you want her to know.
Negative 2 points.
There, I knew you said that.
Right, because we know that, right? But But let's say it's kind of hard to distinguish exactly where it is, because sometimes we'll have graphs, we'll have the window open up really wide, and it might not be on a nice whole number, right? Did you get it, Amy?
4x plus 5y.
She's got to put them in, yes. It ain't?
Here, I'll help you.
Now, once I have these in here, I can use the calculator to actually find that exact intersection point. So now, let's have the calculator find the intersection point, which you know is the what? To the system. Solution. Menu button. We learned how to trace yesterday, right?
Yeah.
But like the tracing doesn't always hit exactly. It goes, you know, it might not hit exactly on that point. So hit the menu button, okay? Do you see any option here that might help us?
Analyze graph.
How about analyze graph? Number 6.
Intersection 4.
There's a whole bunch of stuff here, isn't there? Intersection is what we want. Now, here's what happens. You see that? Do you see this dotted line?
No,
You
mine
got-
went away.
And you've got your touchpad, right? So what you do, it's asking for the lower bound. So you have to kind of see where it is, and I just want to bring that over before the intersection, yeah? And then hit the center of my touchpad. Now it should say upper bound, right? So now you slide this over so you're clearly past that, and then hit enter. So you kind of have to tell it, like, all right, I'm looking for an intersection between where and where, right? Because some graphs you have might have more than one intersection point, especially in parameters. So is that what we got
Yeah.
algebraically?
Yeah.
Okay, so I mean, these can do it for you, right? I do not want you to rely on these doing that for you, because I'm actually here to teach you algebra, right? But, you know, say like on the Regents exam, you just got a quick multiple choice to do, and you just throw it in there, right? Okay?
This is all Ms. Boswell's class students.
Yeah.
Because they're not.
Well, I doubt that's the reason. Perhaps Miss Boswell and I have slightly varying styles. She is taller.
Taller?
That's true.
What? Taller.
She's like a midget.
That's not the right word to use.
Okay, show that the point you found A and B as a solution to the system. Yeah, well, what are you going to do? You're going to plug it in, right?
Yeah.
Okay, got it. So here we go, exercise 2. I want you guys to solve this. Everyone put your calculators down now. All calculators are down. And I want everyone to try and solve this one on their own. Okay? Without, yes, algebraically. So you're going to have to multiply one or both of the equations by something to make a variable go away. So what I notice is, you know, neither 5 or 2 go into each other, and nor do 2 or 7.
They go into 10.
All right. So you're going to have to probably multiply both equations by something, right? Yeah, okay. So why don't you guys go ahead and do that? Think about which variable you want to make go away. One of them has to be positive, the other one negative. So when you add them, they disappear. You found your mistake, and the mistake was you didn't solve it yet.
No.
All right. So a lot of you look like you were going after the x term to get it to go away, right?
Oh, wait, I know what I did. I put 45 instead of 43 at the end.
There you have it. So if I'm going to get rid of the x term, they don't go into each other, but they both go into what?
10. I got negative 105.
Oh, sweet Maria. So let's make that 10x by multiplying the whole thing by 2. But I want this to be negative 10x, so I multiply this whole thing by what? Negative 5, right? So this gives us 10x minus 4y equals 20. Maybe some of you are forgetting to multiply this part as well, right?
Negative
The 10 here, right? 43. So then we get negative 10x
plus 35 minus 35.
minus 35y equals, what is it?
Negative.
Negative 215. right?
I got that right.
Okay, then what did you do next? Did you do this?
Yeah.
That's the whole point of combination. Add them together now. Like, what else could you possibly have done?
I got 4 -5.
It's called linear combination, because you get combine them and one of the things goes away, and, right? So, okay, now that you're on board with that part, look at here. What will happen when I add these? What will go away? Both of what? 10x minus 10x is what? 0.
Yeah, they both go like so.
There's only one thing, it's an x. Okay,
Negative 39y.
So this is negative 39y equals what?
195.
195.
Y equals 5.
Y equals, what is it?
5. Positive 5.
Positive 5.
Negative.
Wouldn't that be positive?
Yeah.
Yeah,
There on your
right.
back, and it's really not.
Okay, so now we got to get the x value.
I just did it. I did everything right. I just didn't do that part. What did you not do?
That's the, like the whole,
I did it.
that is the key.
I did Adam Sandler.
Sorry, that's the key, that's the Christ, the name of the lesson, that part.
Yeah, I didn't do that.
That's what the title of the section is, you see.
He's doing this.
So that's a pretty kind of important part, because they put it in the title. Binding, combination. Anywho, I don't know, let's plug it into,
The bottom.
whatever, bottom one. 2x,
2x plus 35
Yep.
equals 43.
thank you, 7 times 5 equals 43, so x plus 35 equals 43. Subtract 35 from both sides, you get what?
2x equals 8.
8.
Divide by 2. X equals 4.
So it is 4, comma, 5. Everybody able to get that?
Yeah.
Let's try it, huh?
No.
Okay.
We tried
Do you understand now?
Yes.
That's why we wanted these one to be 10 and negative 10, so that when we combine them, add them, they go away. It's in the title, okay?
This is just so hard to do.
Minor combination. I don't.
Linear.
Linear, nice girl.
These are linear equations, and we're combining them. They're linear. At one time, linear, and we're combining them. So linear combination. And the other thing they call it is elimination, I guess, because something gets eliminated when you combine them. Whatever. Let's try this on the calculator.
I already did mine on the calculator.
So you probably want to go into menu actions, right? For delete all.
Oh, no.
So you guys, and then hit enter. You guys that are having trouble with the calculator, keep up with me on this part, right? Now you can hit your tab button. So hopefully it's still in that relation mode, right?
Yeah.
And let's type in 5x minus 2y. You know, basically, you tell me if this works for you this time. I'm not sure what went sideways there. 5x minus 2y equals 10. And just arrow down. 2x is 7y. 7y equals 43. So there's the other one. I'm thinking I want to move that equation out of the way because it might pop up with my solution. I want to go up here. Remember how to do that?
You had
Control, grab. I could delete it too, yeah. That. Now where do I go to find the intersection? Who remembers?
menu.
Menu,
Go down to analyze.
analyze graph,
You go to intersection.
intersection. Now it's asking me for what?
Lower bound.
Lower bound, I'm already to the left of it, right? So I can just hit the center. And now what do? How do I do that? I just slide on my touchpad past the intersection and then hit enter. And we got 4 or 5, yeah?
Yeah.
Okay? You getting the hang of these now?
They're easy. I just don't like them.
It still didn't work for you? Let me ask you a question. I wonder if this is. So when you type this here, you're doing, watch my fingers, 5x, right? I didn't want that. You're doing 5 and then x down here, right? And then this minus here, huh? Minus, and then 2y, huh? And then equals 10. Okay, and then after you type that in, what did you touch? Down arrow? All right, I'll come back and look at that here in a minute. That's a little puzzling. When I did it worked, yeah. I'll have to figure that out. Maybe Serenity can watch you as you type it in and she can figure out.
Serenity knows how to do that.
Well, if she doesn't, she'll be forced to think about it, and this will help everybody. Right? Okay, on the next page, I don't really care for exercise 3 or 4. And you want to pay attention to this. Skip number 6 in problem set. All right, skip number 6 in the problem set. Just kind of annoying, I think. I think so. I thought I said skip. I wrote it too. All right. Let's go down to exercise 4. Got some number stuff again. We're not really going to need the calculator for this one. So set your calculators aside. Mr. Payne. Okay. All right, let's set them down for now. So exercise 4. Amy Fahrenbeck, what's going on in exercise 4? Is that name funny?
What's going on?
Sally, read number 4. That's you. Out loud.
Three numbers have the following properties. The sum of the larger and twice the smaller is equal to 13.
Hey, pause. The sum of the larger and twice the smaller equals 13. Does that look like an equation to you guys?
No. Yeah.
Good. Keep going, Amy.
Twice and is equal to 8. What are the two numbers? Play around with modeling.
No, we're not going to do this. We're not playing around with I don't like it when they do that. We're going to just directly write 2 equations here and by God get the correct answer. All right. So how about we do this? You can use X and Y, but I think I'll use L for the larger number. And maybe S for the smaller.
What kind of L is that?
Well, it's a cursive L. I know they don't teach you guys cursive anymore.
No.
They used
But
to.
that's a cursive L, and I prefer to use that so to distinguish it from, say, a 1 or something else.
Yeah, but that's going to be a 0.
It's an L. I don't know what that means, 0, but that's an L.
Yeah, but you got people like you got when they said 0.
So let's write an equation for this first piece of information. The sum of the larger and twice the smaller. Nope.
What?
So what does sum mean, Serenity? Just right there.
What does sum mean?
Yeah. Thank you. It means to do what? Add, subtract, multiply, divide. Sum.
What? I'm writing this down.
Stop writing a second. I'm not writing anything. The word sum means to do what? Add, subtract, multiply, divide.
Add.
Okay. And, so give me something then. Sum of the larger and twice the smaller equals 13. Tell me what to write. What's the larger?
L
L?
plus S
Well, wait a minute, I thought it was,
2 twice.
so what, Amy? Or what's your face, whatever?
Serenity.
Uh-huh. Dolly?
Twice the smaller.
Alright,
Go ahead.
so twice the smaller, so S times
Or we could write 2s, yeah, go ahead. Yeah,
equals 13.
equals 13. Hey, there's one equation, right? What was so hard? How about this other? That was hard?
Yeah.
Some of the larger and twice the smaller. Hey, there's a larger, twice the smaller. How about this other one? Twice their positive difference. Why would they point out positive difference? Like you have first of all, what's the difference mean? Okay, so if you have a larger number and a smaller number, you want to get the difference. Is there a wrong way to subtract it?
Yeah.
Why? How?
There's one way you could get a positive and the other way you could get a negative.
Right, they want the pot, right. Like if you do the smaller minus the larger, the result will be what? Negative, right? So they want the positive, so we have to do what?
The larger minus the smaller.
Okay. So, Amy, how do we write twice their positive difference?
Spell for larger.
Difference means what? Okay. So let's start with that. The difference between the larger and smaller. Tell me what to write there. You just told me subtract. Yeah. So, that's one of the numbers, that's the other one. What do I write? Let's say that was 5 and that was 3. How would I write the difference of that? L minus S. So L minus S, right? That's the positive difference. But what does it actually say?
Twice.
So what do I have to do to this to get twice that difference? So,
Two.
like that,
Parentheses.
I need twice the entire difference, right?
Yeah.
And what's it going to be equal to? Equals 8. This is old stuff.
Get Rowdy over there.
Yeah.
Someone gets on.
So they want to know what the two numbers are. How do you want to do this? Is this like going to be able to be added up and?
Yeah.
Not quite like that, right? What should we do to make it look like?
Distribute.
We should like use all this.
No, if you distribute the two, it's gonna cancel the S's.
Serenity, should we distribute the 2?
Yeah.
All right, let's do that. Serenity, what do we get when we distribute this 2? Go ahead and tell me what you write after you distribute that 2.
I don't
We're using S's.
No.
2L minus 2S.
No, Serenity,
know. 2L minus 2X.
why wouldn't you have said that?
So I
2 times L, 2 times negative S. 2L minus 2S equals 8. Now, does it look like something we might be able to combine? Let me just bring this up here. I don't want this middle one confusing things. So I'm just going to write it up here. L plus, what's confusing? What are they?
Just the S's, they look like 5.
So it's not really confusing. It's just unclear. All right.
Yeah.
And then 2L
Minus
minus 2S equals 8.
Which
Now, hold on. Hold on here. Amy, if I was to add these two equations as they sit, would anything disappear? Amy only. The S terms, right? So do we have to multiply by anything?
No.
No, this is pretty simple, isn't it? So let's add them up.
3L.
I'm going to just let you guys do it. Find the two numbers. Everyone do that. I should record that. And I don't know, maybe use the top equation there to get the smaller or the bottom, either way.
No, top.
So 7 plus 2S equals 13. So subtract 7, right? 7, 6, divide by 2. And those multiplying. So the numbers are 7 and 3. Does that make sense?
Yeah.
Well, just think of it. Sum of larger and twice as smaller. So it'd be the sum of, what's 7 and 6? 7 plus 6. 13. This can't be. Right? Yeah. What's twice the positive difference? What's 7 minus 3?
4.
Why does it take so long?
Because
And what's twice 4?
8.
Okay, so it does check out. Let's go look at maybe a readings question.
I don't think we have any.
Yeah, we got a couple. All right, let's look these over. Everyone, take a look at number 1. Put some thought into how you would solve this and which one of these choices would make sense. You might have to even, work out a little bit what you would do to see if you can make it look like one of these. Okay? Knowing what we've been doing with, linear combination or even substitution, but probably linear combination. Well, let's just take a look at choice 1 there. Does choice 1, does it look like one of the equations wasn't changed at all? No, okay. So maybe, I don't
Multiply
know.
by 5.
Multiply by what?
They had to multiply by 5 to get the 5x.
Maybe. Possibly. Well, let me ask you this.
Multiply by
Let me ask you this. Is there a way to combine these such that you will end up with a 5x? And what do you notice is missing here?
the y.
Okay. So it looks like in choice 1, what variable did they make disappear?
Multiply the bottom.
What variable did they make disappear? Okay, stop. So now I want everyone to think about what could they have done to make the y disappear when they added them. And that will help you decide if that choice is correct or not. So Sheldon thought, well, maybe they multiplied the bottom by 4 and then did what? Serenity, and then did what?
Added them again.
Yes, so you added them, and then what? So try that and see if that gets you what's in choice 1. If not, then go to choice 2.
I think this is one.
This is not hard. It's so ridiculously easy. That, well, I don't know. I lost my train of thought.
Again?
So when you added them like that, you got 5x?
Well, I multiplied the bottom by 4.
So, right, it looks like they got the y term to disappear, and the only way to do that really is to do this, right? Because there's a negative 4y up top. So that would give us, if we did like this, x minus 4y equals 10, negative 10, and 4x plus 4y equals 20, right? And if I add those, it just didn't take. If I add these, then I get 5x equals what? It's negative 10 plus 20, right? Equals 10. Hey, so isn't that, so they're using this one and that one. Why is the 0 not, like I put it there? Okay.
So I was right.
Right, does that make sense?
I was right.
So you just have to like start playing around with it and see what makes sense. Let's move on to the number 2.
Yeah.
So you're going to think about it similarly, right?
Similarly.
Which system would yield? Well, in other words, it's saying which of these would be an equivalent set of equations to that. And you know what you can do with equations, right? You can multiply equation numbers, you can add them together. So there must be some way of doing that that'll match up with one of these down here. Like, forget these here, what would you do if you were to solve this and you wanted to add them so the variable goes away?
Multiply the bottom by 4 or 2.
The bottom one by 2? So then you get 4x, 6, and 6y. There's no 4x and 6y up top, right? Yeah, there is. There's an x minus y. There's 1x minus 1y, right? But look at, so do you see, like, there's x and 2x? What would happen if this was a negative 2x up here? Do they go away when you add them? Well, how could you make that happen? Multiply the whole top by what? No, negative 2. Right? Because you said you want negative 2x.
Yeah.
So what would this look like if I multiplied it all by negative 2? What would you have? Just tell me.
Negative 2x
Go ahead.
and negative.
No. Negative times a negative is. So negative 2x what? Y equals. It's negative 2 times 3 equals negative 2 times 3.
Negative 2.
Stupid. But it's negative 2 times 3, so it's not 6. Negative 6.
That's not the right answer.
I know, I'm just trying to help you guys walk through a possible scenario, right? So you would have ended up with negative 2x plus 2y equals negative 6 and the other one together.
You put negative equals negative 2.
What did I do? Negative 6. So are either of those, does any of that fit this thing?
No.
All right, so then move on to the next thing, right? What else could possibly have happened here?
Multiply by 3.
We'll multiply what by 3?
Your mom.
Okay, you got to be specific, right? So let's see what happens if we...
No, by negative 3.
By negative 3?
When you already have a negative.
Yeah.
And then positive 3.
How about, but what happens then? We get what? 3x minus 3y equals 9, along with this one here. All right, is that one of our choices?
Oh, no.
No, it's not. No. What else could we do? Hmm?
So, no. What's a no?
So this is definitely, all these choices have the bottom one unchanged, yeah?
And multiply by the top.
Well, now, what if they multiplied the top by something, but then, well, if they added it together, then something would go away. So that would have to be,
Wait, just-
multiply by 2, or if we multiplied by 3,
Would it be negative
it'd have to
2?
be negative 3. I wonder if there's not a typo here.
That's what I was saying, because I was going to go with number 2, but then they didn't multiply the 3 by negative 2. That's what my first answer was.
I think this is it here. I think that should be plus 2y.
I had one.
I wonder if that's a typo.
No, I think it's number 2.
No.
It would be the C.
Huh? What'd you want to say? I think it's one as well, because I'm pretty sure it's one. I think there might be a typo here.
No.
I thought it was 4.
No, it's not. It's
Well, it can't, like, no, 4. If we were trying to get 4, it'd be looking like this, with a minus 3y in there.
yeah,
It's
no.
3.
If you multiply by negative 3, then it would be negative 9, and that would be a typo.
Unless they did, let's see, could the 2, so if they multiplied by
Oh,
positive
yeah.
2,
Yeah, I know.
oh, it could be choice, well, let's see.
What do you have an answer to, girl?
Girl,
Girl.
you need glasses?
I have one.
Let's try,
Then multiply by negative 3.
let's just try multiplying by 2.
I was looking at the bottom.
Well, okay. then let's think about the question. Actually, let's think about, all right, let's talk about it. So, I guess we were thinking about the question not quite right. We were trying to approach it as how would we solve it? We'd make a variable go away. But what they're asking here is about the types of things you can do to an equation, right? And still make it an equivalent equation, same solution. Remember yesterday where we would, in the notes, it was multiplying an equation by something, plugging in the points, say, yep, still a solution. Or add them up, plug in the point, yep, still a solution. That's what I think they're getting at here. So I kind of thought of it quickly like you guys did. See, so which will yield the same solution? And any of these things that you apply, multiplying an equation by some number or adding or whatever, will give you some of the same solution. So it appears to me that choice what would have the same solution. Yeah, even though, and that's the part, even though it's kind of useless to us to solve, right? Because if I add these up, is anything useful going to happen? No. So, got to be careful with thinking about the wording there, okay? All right, one more. One more.
But you didn't show him how to do it.
What?
Oh, here's another one.
So let's think about this carefully.
I don't.
Me.
I don't.
Wait.
Any thoughts on 3?
4.
What makes you say 4?
It'll still be the same, and the Y's and cancel.
Maybe somebody say 3.
I said
You said 3. What makes you say 3? Divide the top by negative 3?
Multiply.
Or you mean multiply by negative 3? Yeah,
oh,
and?
yeah, those can't. Why can't?
Then I have to go.
And then the bottom stays the same? So negative, let's negative 3. That would give us negative 9x plus 3y, right? So, yeah, so that's not gonna work, right?
I think it's number 1 then.
Yeah, I said.
Why do you say number 1?
Because you can multiply the top by -2 and the bottom by -3. and you're-
Well, if we multiply the top by negative 2, you guys like,
I'm at 2.
okay.
No, positive 2.
Yeah.
All right, she said negative, so let me just fix it. So 2 times that would give us 6x minus 2y equals 14,
And
right?
then the bottom by -3.
And this one by negative 3 would give us negative 6x. Yeah, is that going to give us positive 9?
No.
No.
Number 2, actually.
Well, now, yeah, number 2, for all the wrong reasons, right?
No, I said number 2.
Okay, why?
Because
The rest of the game.
When you multiply the bottom by 2, it's going to be 2.
if it's top by 6,
It'll be 18.
So wouldn't that give us 18x minus 6y equals 42, and then 4x, 6y, 24?
Yes.
Now, this one would be helpful in solving it, actually, like the other one wasn't. That was a little catch, all right? So it's just a matter of knowing the things you can do to equations to keep them equivalent, and that's kind of what they're after. This one was a little tricky, because I even assumed they wanted you to do something that was useful in actual solving it, right? But that's not quite what they were after. Okay.
yeah.